Here we have a problem like the previous one where we're given a rectangle, so we have to think about all the special properties about a rectangle. One thing that I want you to think of every time you see a rectangle, the corners are 90. That one's pretty obvious. But the other one that you didn't know before is that the diagonals are congruent and they also bisect each other. So all four pieces of these diagonals are congruent, so I'm marking them right now, and that creates isosceles triangles. The ones that are across from each other are identical to each other. So if this corner up here is 50, being an isosceles triangle, this is 50 here, and then the triangle opposite it has those same angles. And then if a corner is 90, subtracting 50, you can find the other angle that makes up that corner, and then across from it is the other isosceles triangle that's matching to it. So you're able to get all the corner angles that way. And then you can find the central angles by, looking at the triangle and knowing that it adds to 180. So 40 and 40 is 80. That leaves 100 for this other angle. And then these side by side, they make 180. So you can figure this out that way, or you can do 50 and 50 is 100. Subtract from 180 to get the 80. So now I have all the angles marked. And let's see, some are asking for angles and some are asking for side lengths. And up here they gave us one, they said XZ is 12. That's the entire diagonal, and so that means that each side of it is 6. And so that means that all the diagonals are 6. So let's see what all we can answer just from that. WXZ. Angle WXZ. So W to X to Z, that's a 40-degree angle. WPX, W to P to X outlines the 100-degree angle. PY, that's this part of the diagonal, which is 6 because it's half of a diagonal. So I answered 3 out of 4 without doing too much work. To get WX, I'm going to need to use some trigonometry here. So I want to outline what I'm doing. What I'm going to do to find WX is I'm going to use, since I don't have a special right triangle, I need a right triangle. So what I need to do is use this diagonal of the rectangle that's outlining this part. And remember, I already got 3 out of 4 without doing this. So pick an angle to use as your reference angle to base everything off of. So I'm going to use the 40. That means that this would be the opposite, this would be the adjacent, and I know the hypotenuse is 12. I'm just going to put that over here. And so I'm finding A, and I have H, that's cosine. So cosine of 40 is adjacent, which is what we're trying to find, over the hypotenuse, which is 12. And so I'm going to solve this like we did trig. So 12 times cosine 40 is X. So I'm going to enter that in my calculator. 12 times cosine 40 gives me 9.19. So that is WX. So 9.19 is that one. So we only had to do that for one out of 4 here, so you don't have to do that very often. The square it has the most things special about it, and that actually makes it the easiest thing to do if you remember everything about it. Square has the properties of a rectangle, so it has right angles in all the corners. It also has congruent diagonals, which means that all 4 of these diagonals in here will be the same, so that I can label them all 5. It has the properties of a rhombus, which means that in the middle the diagonals are perpendicular, and that the diagonals bisect all of the angles. So bisecting a 90 degree would mean that I have 45-degree angles in each spot. So each of these angles, they're all 45 degrees. So there's a lot of special things to remember about a square, but that makes you hardly have to do any work if you can remember them. So what this means is that I have a 45, 45, 90 triangle. So I'm going to go ahead and apply that rule to get the outside length. So that rule is x root 2. So across from the 45 is the 5. So under the 45, 5, 5, and then the 90 is 5 root 2. So opposite from the 90 is the 5 root 2, which means that all of the outside sides are 5 root 2. So now I know everything about this square, and I can answer any question. So angle GHF, so from G to H to F, that's a central angle. That's going to be 90 degrees. D to G to H, DGH, that's that 45-degree angle. HF, one part of the diagonal here, it's 5. And DE is that outside length, 5 root 2. And that's everything from the square. So had to use that special right triangle in there, but other than that, it was pretty easy. And that is the last one for this section.